guys. Today in Conics we will be looking at circles. The goal is that we graph and write equations of circles, and then we'll use those skills to solve real-world problems, including those problems that you guys are looking at for this unit's project. So, a circle is defined by a set of points that are equidistant from a fixed point on the circle, and that fixed point is called the center of the circle, which is just the center. And then the radius will be the distance from that fixed point to any point on the circle. So I'm talking from that fixed point to any point on the circle will be our radius. So there are two equations that we need to be familiar with. That is the standard form and the general form. The standard form is in the form x minus h squared plus y minus k squared equals r squared. That equation utilizes the center, which is called hk, and the, x and y are just the variables that define points on the circle. And then note that the r is squared in this case. And then the general form, which we'll address kind of towards the end. Okay? That being said, let's get right into it. So this formula does not just come from anywhere. The standard form of the equation of a circle comes from something that we ought to be familiar with. I'm referring to the distance formula. Okay, so given that the center is always fixed and we want to find that distance from the center to any point on the circle, which means we want to find the distance of the radius, we can use the distance formula, which assuming this is the h and the k and that's x and the y, given those two, we can simply use the distance formula, substitute in the information that we know to give us r, and then to put that into the equation of the standard form of the equation of a circle, we need to go back and just notice that in this case the x, the center was at 0, 0, which means everything simplifies to just leave x squared plus y squared equals r squared. Notice again, for the standard form of the equation of a circle, the r is squared. And what combines the x's and the y's is a positive. So we also need to note that. So this will be the simplified form of that equation, or that formula, the standard equation of a circle, the equation of a circle, given that in this case the center is at 0, 0. So you guys go ahead. Write on your note or on your practice sheet, what is the equation of a circle with a center at 0, 0 and radius r? Pause and write. Okay, so hopefully you got that. That was simply the standard form of the equation of a circle with a center at 0, 0, which means just x squared plus y squared equals r squared. I hope that's what you got on your papers. That being said, let's do this next practice here. Draw a circle given by that equation y squared equals 25 minus x squared. Okay, I went ahead and did it, but you all also need to practice on your papers. I need to rearrange this so I match up to the standard form of the equation of a circle. That means I'll bring my negative x over to the left side. That will be y squared plus x squared equals 25. And remember, that's always r squared. And in order to find that distance r, I just need to take the square root of 25, which gives me 5. And then I draw my circle since I know where my center is. In this case, my center is at 0, 0, because notice that this was the simplified form. The x is isolated, the y is isolated. My center must be at 0, 0. So here's another practice. What is the radius of a circle given a point P on the circle that is at the location 1, 4 and the center is at the origin? So right away when I read this question, you guys pause it and do it and then compare with what I got. Okay, so right away when I read this question, I see center at origin. I already know my h and k are at 0, 0. So I write out my standard form of the equation of a circle. I substitute my h and k with 0, 0, and then I was given a point. That was another piece of information that I was given, 1, 4. So I go ahead and substitute the x with the 1 and the y with 4 and just solve that out, and what I get is that r squared equals 17, but the question was what is the radius of the circle. So in order to find r, what I need to do is simply take the square root of 17, and for exact values I'll just leave it at r equals square root of 17. So is the center always at 0, 0? Absolutely not. That's why we have the variables h and k. The h and k, basically they mean that we can have the center at any quadrant. We can have it slid up and down the y-axis. We can have it slid left and right the x-axis. It could be at any position. So and then the provisions of the standard form, having that h and k there, give us give us that opportunity to basically substitute in whichever location that we choose for the circle to be. So this slide right here just shows you that the distance formula again just goes back with the definition that we were given for a circle. The fact that we have equidistance from the center of a circle to any point on the circle. So in this case, HK will represent that center, whichever location it's at, and then the X and the Y will be any point P on the circle. And so up here we begin with the distance formula in order to find that R, and then once we've found the R, we just go back and what we're doing here, actually these two are the same. These two, but it's okay. So I just really like the standard form of the equation of a circle, so I wrote it twice. But again, it's x minus h squared plus y minus k squared equals r squared. Notice that these two are connected with a positive. And another thing is that the h and the k, when they're introduced with negatives in front of them. Okay, all right, moving on. So again, I just really like the standard form, so I wrote it over and over again. But I did that intentionally so that you all could get really familiar with it. X minus h squared plus y minus k squared equals r squared. That is the standard form. And where is the center in this case? In this case, the center will be at hk, and notice that on the right side it's always r squared. So in order to find r, I have to find the inverse of square, which is take the square root of the r squared. Okay, so enough of me talking. Let's get to an example. Pause this slide and you guys attempt it. Graph the circle. I hope by now you have something on your paper. So when I look at this, there are lots of pieces going on. So right away, the first thing I want to point out is, do I know where the center is? So I see this time the center is not at 0, 0 because I've got an h and a k here. So I go ahead to the x part and I see, okay, it's combined with a negative. Good. So I just grab the 2. And then to the y, there's a positive 1 here, but these are normally combined with negatives like inside the parentheses. So then it must have been a negative 1 to begin with in order to end up being a positive. So when those two negatives combine. So I'll take my center as 2, negative 1. And then remember, on the right side we have r squared, and I need to find my r, which will be square root of 25 is 5. So now I have a center at 2, negative 1, and I have an r of 5. At this point, I just go 1, 2, negative 2, negative 1, and then I just count out 5 distances each direction and just draw my circle. I did so right here. Pause it and compare it with your work to make sure that you did it correctly. Here's another practice. Pause this slide and try it by yourselves. So we have 2 points, And this time, we don't know where the center is. So in order to find the center, we're going to have to do a little bit more work. So we're given like a diameter and those 2 points. So the question is, how do we find the center? Remember, the center is equidistant from every point on the circle. That means we can use a little something called midpoint formula to find the midpoint, because that will give us the center. So that's what I did here. I had to look it up. I couldn't remember it. And I ended up finding that my midpoint was at -3/2 and 1/2. And I have more pieces of information. So when I came down here, I plugged in my h and my k. And noticed that since this was a negative, down here it ends up being a positive. And then I just used the point -4, -1. I substituted in for all the variables. I solved for r squared. And after that, I needed to find r. So I will probably end up finding the square root of this value, which will give me 34, square root of 34 divided by 2. All right, I'll be checking your papers to see how you guys approach this. And just another thing that we really need to mention, which is very important, is how do we change from general form to graphing form? So pause this slide and read through this slide. So first we have to group like variables, and then we have to factor out leading coefficients. Complete the circles for both variables since the x is squared and the y is squared. And lastly, we have to divide the leading term. Okay, the only way to do it is by doing an example. Here we go. So copy this example down and try it on your own to start with. And let's use the guidelines on the previous page. So, okay, I tried it as well. What did I do? So I went ahead and grouped. I write my steps on the right side. I grouped the x's and the y's. And to me, dealing with x's and the y's both together at the same time was too much work. So I decided to deal with the x's first. So what I did is I collected my x's and everything else went to the right side. I completed the square for the x's, and notice I add 1 and 1 here. That is the step for completing this. That was part of the steps of completing the square. I'm done at this point. I'm done completing the square for the x's, and I'm like, okay, we gotta do it for the y. So I just take this and I negated it to move it to the right side so that I could bring the y's over to the left side so that we could complete the square for that too. I went ahead and completed the squares for the y. So at this point, I've completed the square for the y variables and for the x variables. So what I need to do at this point is rearrange the equation so I match up to the standard form of the equation of the circle. So when I bring over the x's and the y's to the left side, okay, so I needed to bring this back to the left side. I did a mistake where I'm supposed to just change this to a positive so that when it comes out here, I have plus x minus 1 squared, but I changed this to a positive, which is a mistake. That's why I just edited that right there. But when I bring it over, I simply have that as it is, and then plus x minus 1 squared equals 13. In this case, my r squared will be 13. And just for notation wise, I rewrote the x's first and then the y's next, and just to match up with like x minus h squared plus y minus k squared. And notice that this time we have y plus 3, which means if I ask you where is the center would be at 1, -3, because it had to already have been at a negative location in order to end up with a y plus 3 in the equation, the standard equation. All right, guys, that's all for today. More practice coming right up.